Okay, so this is the last problem of the topic, and this is example 4, and it goes like this. So find the increase of water volume given the following information. So height of the tank, 24 centimeters. Radius of the tank, 6 centimeters. Now, the rate of water level rising the rate of like water level increase, maybe let's write it this way, water level increase is 15 centimeters per minute. And we need to find that volume increase at 9 centimeters. So water level is 9 centimeters. Okay, so let's start with the picture. Okay, so here's the conical tank. Radius, some kind of central line. Height of the tank was, I believe, 24 centimeters, and I'm going to mark it as a capital H, right? For just to distinguish it from the height of the water level. So this is 24. That radius is 6. And what else? We have the water level. Right, so this is all water. That radius here, I'm going to mark it as lowercase r. Right, so that's something we don't know what it is. This was 9 centimeters. And that increase is actually constant, right? So 15 centimeters per minute. So we have a couple constants and many variables. Lowercase r, bigger, capital letter R, H, and this is lowercase h. Let me change. I think it already is blue, so equals H. Okay, yeah, so let me write kind of here in the corner what we know and what we need to find out. So let's start with the dimensions of the tank. So height of the tank is 24, radius 6. Then I have the lowercase h, right? So that's the level of the water at which we need to find that volume increase. It's 9 centimeters. Then so this is the increase in water level, dH dt, lowercase h. That was 15 centimeters per minute. Okay, and we need to find the increase in volume. So dV, volume of water, dV dt. Okay, so that's our unknown. That's what we're looking for. Okay, so first step was to find that, right, those two the formula or the equation that ties those two unknowns. So in our case, the main what are the unknowns? Well, there are actually 3, right? It's the volume, it's the radius of the water, and it's the height of the water. So the formula that would tie all those variables together is simply the formula for volume of a conical shape, right, of a cone. So it's 1/3 pi and then r square times height. Right, so it's a 1/3 of a cylinder basically, right? So pi r square is the is the area of the circle, and height is the height. Okay, so now the problem is that right now we have 3 variables, right? So we need to replace one of them with something else, with the other. So I'm going to use that. I think it's called the law of similar triangles, and basically what we have is two. We have 2 triangles, and I'm going to maybe quickly. I'll quickly draw the whole thing. Okay, so that's that conical tank. This is the radius. I'm going to make that maybe red. Okay, so let's make it red. All right, so we have. So here's one of those triangles. This is the capital H, right? Height of the tank. This is capital R, height of the radius of the tank. And here's the water level. So I'm going to draw that other triangle in blue. So here. Right, so I hope you guys see those triangles, right? So this is lowercase r and this is lowercase h. Okay, so now, right, so the law of similar triangles just says that the ratio of that, of capital H over r is the same as the ratio of lowercase h over r. And yeah, we could either solve it for h or solve it for lowercase h or lowercase r. Right? We're trying to replace either this variable with h or this variable with r. Right? So in my notes, I have, what do I have? I have, I'm replacing r with h. So let's do that thing. So I'm solving for r. Right? So I'm solving for this variable. So I'll have r, and equals capital R times h over h. Okay, I'll plug in the numbers. So r equals, I think it was 6, h, height was 24. Right, so r equals h over 4. Okay, so I have it. So I'm going to replace r with that right, with this formula. So I have v equals 1/3 pi. Right, so I think this was the most difficult part of this problem, right? Because you're looking at this, and yeah, you can take the derivative, right, and do all kinds of stuff. The problem is that you will end up with three quantities that are changing, right? So you would have volume that's changing. You would have dr over dt and dh over dt, right? And now you just have too many variables, and you would not be able to figure it out. So I think that's the most difficult part of each of those related rates problem, right? Coming up with this formula is relatively easy, but then getting rid of one of the variables on the right side is, I think, the most difficult part. Anyway, let's finish the problem. So instead of r square, right, so now I'm replacing, okay, so I have this, right, I'm plugging it right there. All right, so that's gonna be h squared, right? I'm squaring this quantity, divided by 16 times h. Okay, so after I simplify it, I get 1 over 48. 48, then we have pi, and then we have h to the third power. Okay, so now it's doable, right? It's because now we're going to take a derivative of both sides. I'll end up on the left, I'll have, on the left I have what I need, dv over dt, right? That's what I'm looking for. On the right, I'll have h, right? I have that. I have that 9 centimeters. And I also will have dh dt, right? So that's after I take a derivative of this. Now, and that dh dt was, I believe, 15. Okay, so taking derivative of both sides, right? Again, implicit differentiation, so dv dt. The left side is simple. Here I have that 148, that 1 over 48, that doesn't go anywhere, pi doesn't go anywhere. Now, taking derivative of that h to the third. Okay, so so that's going to be 3h squared, and then the dh dt, right? Okay, so yeah, we have that, and the last step is just plugging in the numbers, right? So we have dv dt. One over 48 pi. Now I have 3 times, what was that, 9 squared. Okay, and then dh dt was, I believe, 15. Right, so I don't need this. Don't need this part. I have 15. Okay, so we do all this arithmetic and we end up with dv dt equals 238 centimeters cubed per minute. Okay, so yeah, so that's the answer. And let me quickly review what we did. Okay, so the problem is, where's the problem? Here's the problem. So what are the quantities of, let me maybe first explain what we're doing, right? So the water is being poured into the tank, and that rate is actually not constant, right? What is constant is this rate, right? The increase in level. Right, normally it would, I guess it would be the other way, right? So you're pouring water from some kind of source, right? Faucet or whatever, and that rate would be constant, and this rate would be changing, right? Then it's just another type of problem. But in our case, it's actually the opposite way, right? So this is constant, and this is changing. Okay, so we have a tank, we have dimensions of the tank, then the water level is rising, and we're supposed to figure out what the increase of volume is, right? Remember that that increase is changing when water height is 9 centimeters. Okay, so we came up with the formula that ties all those quantities together. Okay, so this one. Now the problem is that we have 3 variables, right? 1, 2, and 3, and we need just 2. So the way to replace what we did, we replaced that r with h, right? We used the law of similar triangles. So you have the red triangle, right? So that's this one. And then we have a blue triangle. This is this one. Those ratios are the same because these are similar triangles. We solved for radius. I simplified it. We got radius equals h over 4. And then after that, right, it's quite doable, right? We plugged in that this over here, right, the green thing. We got that. Simplified it. Took a derivative of both sides. And the left side easy. The right side, I hope it's easy too, right? Implicit differentiation. This is my outside function, this is the inside. So derivative of the outside is this, and then times the inside. And then we just did arithmetic, plugged in everything we know, and this is the answer, right? So that increase of volume at that particular frozen one moment, right, is 238 cubic centimeters per minute. Okay, so that is it for 3.9 related rates.